In this video, we're going to be discussing logarithmic differentiation. The technique is this: if y equal to the natural logarithm of u, then differentiating y with respect to x will be the differential value of u itself over u. And if y equal to log u base a, differentiating y with respect to x will be the differential value of u itself over u multiplied by the natural logarithm of the base number. Let's take a look at some problems here. The first one, let's assume you have y equal to ln x squared plus 4. We're asked to find the y dx. And then we can say that our u equal to x squared plus 4. And then differentiating u, of course, is going to be 2x. That is 2 multiplied by x raised to the power 2 minus 1. And the differentiating 4 here is going to be 0. So the y dx, don't forget, is meant to be u prime over u. And therefore, the y dx, it's going to be equal to, the u complement is 2x over u itself, x squared plus 4. So that is the answer to such a question. Let's take a look at another example. Here, if y equal to ln x squared minus 5x. So we have to find the y dx. In this case, our u is going to be x squared minus 5x. So the differential value of u is going to be 2x minus 5. And therefore, don't forget the concept of the y dx equal to u complement divided by u. And in this case, our the y, the x, equal to u complement itself is 2x minus 5 over u, which is x squared minus 5x. So that is the answer to such a question. So let's take a look at another example. Here, if you're given y equal to, this is another example, y equal to 8 ln 5 minus 9x. So in this case, we can say our u equal to 5 minus, our u equal to 5 minus 9x. And therefore, the u complement is going to be, u complement is going to be negative 9. When you differentiate 5, it's going to be 0. Differentiating this, that's going to be negative 9. And therefore, the y, the x, equal to the u complement divided by u itself. So in this case, our the y, the x, equal to, so when you differentiate this complement, it gives you minus 9. But don't forget, we have 8 as a coefficient of the natural logarithm of 5 minus 9x. So that has to be involved when you're computing your answer. So this is going to be 8 in the brackets, negative 9 over the u itself, 5 minus 9x. And of course, this can just be written as 8 times minus 9, which is negative 72, everything over 5 minus 9x. So that is the answer to that question. Let's take a look at another example here. If we are given y equal to 5 ln x raised to the power of 4. So in this case, our u equal to x raised to the power of 4, and then differentiating u, that's going to be 4x cubed. And therefore, the y, the x, which is u prime over u. So by the y, the x equal to 5, since it carries 5 as a coefficient there. So the computation will be 5 in the bracket 4x cubed over x raised to the power of 4. And then eventually we have 25 times 4, which is 20x cubed over x raised to the power of 4. And of course, this can be written as, of course, x cubed out of x raised to the power 4 here can be used to cut out that. And that's going to be 20 over x. That's our final answer. Then let's take a look at another example. Here we have, if y equal to ln x, okay, and therefore in this case our u equal to x, and our u prime, of course, differentiating x, that will be 1, and therefore differentiating y with respect to x is going to be u prime over u. So in this case, differentiating y with respect to x is going to be 1 over x. So that is the answer to the differential value of natural logarithm of x. Let's take a look at another example. Here we have y equal to log 3x plus 4 in a bracket base 2. So in this case, we have our u to be 3x plus 4, and then differentiating u, and that's going to be 3. And then don't forget the base number is is 2, and therefore let's write it as a equal to 2. And therefore the concept says differentiating y with respect to x, okay, is going to be u complement over u multiplied by natural logarithm of the base number. Therefore, our final answer to this question is going to be the u complement itself is going to be 3 over u, which is 3x plus 4 in the bracket natural logarithm of 2. So that is the answer to such a question. Let's take a look at another example. Here, if you're given y equal to log x to the power of 5 minus 9x in the bracket base 4. Okay, that means our u is going to be x raised to the power of 5 minus 9x, and then the u complement itself is 5x raised to the power of 4 minus 9. And then a, the base number, is 4. And then bringing in the techniques of our log differentiation. So the y dx is going to be the u complement over u multiplied by the natural logarithm of the base number, which is ln a. And therefore, our the y, the x, is equal to, the u complement is 5x raised to the power of 4 minus 9. Everything over x raised to the power of 5 minus 9x multiplied by ln 4. That is the answer to such a question. Let's take a look at another example. Here, you have if y equal to 7 log 5x base 3. So in this case, our u equal to 5x. If our u equal to 5x, then the u complement is going to be 5, and the base number a is going to be 3. And therefore, differentiating y with respect to x will bring up our techniques of log differentiation, which is the y dx equal to u prime over u ln a. And therefore, in this case, our the y dx equal to 7. Since we have 7 as a coefficient of our question there, so it's going to be 7 in the bracket 5 over 5x ln 3. Okay, and in this case, we can just write it out as this is 5x. You can just write this as 7 times 5, which is 35. Therefore, here is 35. Everything over 5x ln 3. And then if you look at it carefully, you can still use 5 to divide into 35. 5 here 1, 5 here, that's 7. And in that case, we have 7 over x ln 3. That is the answer to such a question. Kindly subscribe to my YouTube channels.